Okay, perfect. Well, I just initiated our recording. Thanks again for everybody joining today. Hopefully you'll find this to be a very educational session. Today's webinar, we're going to be starting to look at the 808D milling control, and we're going to be specifically looking at working with part programs that have been programmed through a CAM system, imported into the control. We're going to go through a bunch of different steps on handling them, and certainly Cycle832. My name is Chris Pollack. I'll be your presenter for the next hour to an hour and a half, depending on how quickly we get through the content. I can be reached at this contact information. I'm a dealer support specialist with Siemens, where is specifically the East Coast, but no matter where you guys are located, you can always reach out to me as a resource within Siemens. We've been doing these live seminars now for maybe a better part of 8 months to a year now, and just trying to make sure we can get a seminar out about every 6 weeks is what we're shooting for. So coming up shortly, beginning of March, we're going to have a program guide for turning. So this is going to be more 828 and 840 centric, and it's going to be specifically on controlling a program. Then after that, keep looking for that. And just to make sure everybody's aware, these are this is our main website that I wanted to make everybody aware of. This is our CNC for You website. It's a great resource for you. As I'm recording this one now as well, the other ones get recorded. Please feel free to use it as a good resource for you guys. Send customers or colleagues to it to be able to gain more insight and information into the Siemens product. CAM-based programs. Once we start to go through some of the mechanisms of dealing with a CAD-CAM-based program, we're then going to even leverage our high-speed cycle, Cycle832, to try to improve the performance of such programs. As well, in the 2.5D world, we're also going to get an opportunity to not only build a Siemens posted program, but what's called an ISO program. And in our world, an ISO program is like a Fanuc style program. So following more of their protocols as far as CAM cycles are concerned. So that's some of the content we'll be going through in this session. They're actually running in G290 mode, so you'll hear me refer to it as G290 mode. Typically, you don't have to actually tell it to be in G290 mode. The system does it all automatically, but you could in your part program if you wanted to. So this is going to be the example we're going to look at first. So this is a little program that I created and posted out of Mastercam. It is a 2.5D cutter path, a very traditional type of scenario that we would see in a lot of applications. We're going to do some contour milling. It's where you see a profile around the outside of the shape of this part. Then we're going to come in and do a helical bore in the center of it with an end mill. And then we're going to spot drill and drill 2 holes in the part. When we get to handling the profile of the physical part, we're going to have it posted with cutter comp as a wear type of function. You'll see that a lot in CAM posted programs. What that means is the actual output cutter path is already compensating for the radius of the tool, but you're still going to see a G41 or 42 command turning cutter comp on, so you can still adjust the resulting cutter path. And there's some challenges when you get to working with systems like that. So we're going to talk about it, show you a few different tricks, and apply that through. I do want to take a few minutes just to do a brief overview of the jog screen. I have gone through some of this content in previous webinars on the 808, so I don't want to spend a lot of time going into the detail because we have a lot of content to cover. But when you see some of the functions here, when we switch over to the ISO side of the world, you will lose some of these functionality. So I want you aware of what's here now, so when we do get over to ISO, you're going to see what the differences are in the control. So this is a few of the functions we're going to take a look at quickly, but we are going to take a look at measure tool, measure part, TSM screen. As well, we're going to go into the offset table. We're going to actually build some tools as we start to methodize the programs and take a look at some of the offset areas. From there, we're going to switch over to our Program Manager section. And this goes into the area where we actually manage part programs. So we're going to start transferring files in and out of the control. We're going to build some directory structure, create some file structure so we can copy programs in and out. I'll show you some tricks as to how to just kind of streamline how you methodize your parts and track your parts. From there, we're going to go into our event editor. This would be our G-code editor, and start to look at some programs. We're going to start to play around with a couple different examples. I have these scenarios posted out for you, and we're going to get to kind of see what the whole process is about in dealing with CAM-based programs. We'll go and simulate it just so you can get an idea of what's going to happen prior to running the system. And then we'll... All right, so everybody should have the 808 on PC SINUTrain running right now, currently. This is currently booted up in a 3-axis machine model. This is a fully functional simulator, so I can go as far. You're going to see some key functions that we use quite commonly in the setup of the machine. First is the TSM window. TSM allows us to do quick tool changes. If I want to change what tool is physically in the machine, right now I see that I have 2 0, so there's no tool physically selected in the machine. If I want to fire up my spindle, turn on my spindle. So it really keeps us from having to go to an MDI type of protocol to be able to do some of these functions. I can go into measure workpiece, and this allows me to set zeros or set offsets. So I can find the edge of a part, I can find the center of a part, whether it be a block or a boss, and I can set zeros there. And these are very key functions when I'm starting to set up a machine. Same thing with the measure tool function. Measure tool allows me to set tool lengths on any given tools, assuming I had a tool set up in the machine. I do not currently right now. From there, we are going to switch over to the offset screen. In my offset screen, I will start to create some given offsets and start to establish different tools and different tool radiuses. Okay, so we have a couple tools created here. We'll start to go through, talk about those tools, play around creating a few more new tools at this point. All right. From there, what I want to do is I want to transition over to my Program Manager section. Now, I'm navigating through the different screens with this keypad on the right side of the display. You're going to see my mouse kind of hovering over it. So with that, I can navigate back to the machine area. That's my jog screen by hitting machine. I can go right to whatever program was last edited with this program button, or for what I'm doing right now, I can select the Program Manager button, and that's going to get me to the area where all of my part programs exist. Okay, so I'm going to go over to part programs, and we're going to start to come into the system and take a look at file structures and whatnot. Now you'll see that I have a few directories already created here. I'm going to delete them. We're going to kind of start from scratch right here. RS-232 is available, and then the advanced system network capabilities are available as well. So with that being said, if I was to look at my USB stick, I have a folder here where I have some part programs, and I have a few different programs methodized. So we have an ISO or Fanuc-based program, and I type out the G290, I select the OK key, and it builds up a folder. From there, I can start to create other folders. Certainly I don't need to use folders. I can have part programs residing right in this directory. As you see here, I have an example one, this MPF file, main program file. But what I am going to do is I'm going to go into my G290 directory, and this would be the source as to where I want to copy that program to. So when moving files in and out of the control, it is very simple. You're just going to use your cut, copy, and paste commands. So I'm going to select the USB. I'm going to navigate into it. So I'm going to use my arrows when I'm on the machine to move my cursor around. I'll hit input to go into a folder. If I want to back up, I just want to be on this top folder. I can hit input again. It'll back me up. So I select input. I drill down into this Siemens folder. I highlight my resulting program, copy, select my NC. It's going to leave me at the folder I was last in. So now I can simply hit paste, moves the program into the part memory. So now, if I was to back all the way out, I'm back at the root directory. If I go into the G290 folder, I now see this part program. So let's open up the program. To open up a program, to simply highlight it and press your input key. And that's going to start me editing. So this is a very traditional G-code structured program coming out of a CAD/CAM system. So you're going to see a bunch of notes here at the top. So these are certainly very handy. So I have some tooling notes. I got a few different tools defined for me, as well as maybe posting time, source files, that kind of stuff. Then from there, anything below these semicolons, so all the semicolons are what we call comments. So anytime you want to put any type of user note in the program, just simply put a semicolon. Everything after it will be ignored. Then I start to see the header protocol, my tools, my tool changes, some technology statements, and we can start moving down from there. I see my spindle commands, different offsets, different things being fired here. So first things first, when I'm methodizing or setting up a new part to start to simulate and then eventually run, is I want to make sure that I have the appropriate tools created or set up for me in my tool table. So I see T1 through T4. So what I'm going to do, and I certainly have a little reference here on these tools, I'm going to go over to my offset table by selecting the offset key right over next to my machine and program button, and that's going to put me over to my tool table or my work coordinate table. Tool list is the tool table, work offsets where my part zeros are stored. Now I do have a couple of tools pre-created, but I'm going to build some new tools for you. Instead of cheating and using the ones that are here, I'm going to delete them and we're going to build them out. So right now I only have two tools in my library, tool 8 and 9, which are used later for a surfacing program we're going to look at. So in this case, when it's time to build a new tool, you're going to hit the new tool option. And these are your 4 primary tools you get within the 808 control to build: milling tools, drilling tools, taps, and ball end mills. So a milling tool would be a standard end mill, face mill, something along those lines. So in this example, I have a 3/4 inch end mill that's going to do my primary rough machining around my peripheral. Then we have a 3/8 end mill to do the helical hole in the center. And then we're going to use a center drill, which is 3/8, and a quarter inch drill to drill the holes. So if I select milling, simply type the tool number. Now this would probably be one of the first things you're going to see that's a blaring difference between the 808 and some of our more advanced controls like the 828 and the 840. And that's the fact that in the 808, you only can assign tool numbers as names. When you get to some of the other controls, you can actually get a little more creative in your naming terminology. Once I've built a tool, I'm just going to assign some dummy offset to the length. Traditionally, this will get set by that tool length function we saw briefly earlier. When I want to set up my tools, it'll write to here. Then it asks for me for the tool radius. Now, I said it was a 3/4 inch diameter. If I want to cheat and not have to do the math externally, you can bring up a calculator on the 808. So on any input field, if you hit the equal sign, it'll bring up a simple calculator for you. So here I can tell it what I need to calculate. In this case, what's half of a 3/4 inch end mill. Hit my accept key, and it writes it immediately into the field. So you can use that certainly in a part programming area. Just remember, hit the equal sign, and it'll bring up the calculator for you. So tool 1 is in the system. Now I'm going to create tool 2. Tool 2 again is an end mill. I said it's a 3/8 end mill, so I happen to know that the radius on that's 187. And our length. I'm going to do a third tool, which is going to be a drilling tool, tool 3. Tool 3 in this case is a 3/8 diameter spot drill. So again, 187. I don't necessarily have to give it, obviously, the radius for a drill because there's no cutter comp associated with it, but I can. Sometimes it's nice from a reference side. And then I'm going to do a final tool, which is going to be one last drill, tool 4. And we said this was a 1/4 inch drill. So that's a 125 radius. And I'll just give it a simple tool length. Okay. So we have our base offsets too. And this is probably one of the first areas where the way the post is set up can dramatically affect how your part programs work. The post I'm using here, and the post and the protocol that this machine is running from is really no different than an 828 and an 840. This is the same post that I actually use for 828 and 840 machines. However, this post was written for a machine that has a random style tool changer. So what this cheat code right here is doing is it's actually prefetching the carousel for the next tool. Unfortunately, this machine that we happen to be on is a carousel tool changer, meaning I can't randomly set up my tools. Well, you're going to find that depending on how they commission the machine, this can create some interesting results. So we're going to run this program, and then we're going to try a couple things, and we're going to notice that nothing's changing. And then I'm going to show you kind of what's happening here. But these are the things you're going to start to have to deal with when you're dealing with post processors, especially debugging them. A lot of times it's designed for one machine or one control. You're trying to apply it to a little different machine that was set up differently, and you may get two very different results. Okay, so if we go simulate and we start to run this part, and I'm going to zoom in. You're going to start to see the machine come around. It's applying some form of cutter compensation. Okay. Now, this is this first area that you have to start to pay attention to when you roll around the cutter comp. What's happening right now, and what you don't know, which I already know because obviously I methodized all this stuff, is that we think that this machine should be running tool 1. Well, the way the parameters are set up in this machine, it's loading the offset based on the T code, not necessarily the M6. So one of the first things you might do would be say, well, what would happen if I went to tool 1 and I dramatically changed my radius to maybe a 0? What I would expect to happen when I simulate it is I would get a different result. But yet when I look at this profile, I'm still going around the exact same path. So no matter how I adjust the radius on this program, it doesn't seem to have any resulting change. Well, what's really happening is if I was to really run this part, it's actually loading the offsets for tool 2 because they have set this machine up to prefetch, but this actual machine isn't designed for prefetching. So watch what happens when I simply just delete this instruction that's not needed. Now, if we go to simulation and we rerun this part, now we see a completely different cutter path. So it's very important to start to understand how these commands build and understand that depending on the technology of the machine I'm on, they may function very differently. Okay, so what I really wanted to start to show you here, and this is very common when dealing with a posted program where they're compensating for the tool radius already. Let's run this. So right now, I have the tool offset, tool 1, set up at a 0 cutter radius. So this would be the actual cutter path I would need to cut this part accurately. So if I put any offset in here, so let's say I put it back to that 375 radius, because this is a 3/4 inch end mill. Now as I start to run the program, and we cycle start it, now you see how it's pushing the compensation out. Now my part is now oversized, and it's oversized by that radius. So we see this is center line of the cutter. So you want to be careful when you're posting programs that, how do I handle this? Well, you've got a couple different ways to handle this. Certainly, probably the most common way when dealing with programs that they want to have some ability of adjusting an offset out of the machine, it's called outputting from the cam side, outputting where, is it's still going to output a 41 or a 42. I can see my G41 is here. We always hide it on me, right there. So there's your G41. This is what's turning on the comp. If that wasn't there, this issue wouldn't occur. But since the 41 is there, I either have to set up my tool with a 0 as my radius, and then as I adjust it, I can put maybe a small adjustment value here, And then as I simulate it, I'm going to get a new cutter path just off of that. So now you see, I'm going to zoom in for everybody so you can really start to see it. And let's move over a little bit. I want to get right in here. All right. So now I see, all I did was, in this case, I put 25 thou, a little larger than I would in real life, but I wanted you to get a chance to see the different cutter paths. So normally, TOFFL, and then I can adjust the length of an offset. So what that's doing is it's saying, okay, I understand you're telling me I got a 3/8 tool, but in reality, I'm going to take that 3/8 away before I run the cutter path, but you still have cutter compensation. So if I simulate that same part program, I'm going to delete the window so we'll get a fresh simulation. I'm going to see the same results as I would have had before. So I'm not getting double compensation. This edge of this part would have been at 2 inch. That's correct. And now I can just add or subtract to this diameter like a real world scenario. So if I think it's a couple thou over or under, I could put the true value here. So let's say 0.4. I'll put a big number, for instance. And I run it. And now I see, like we saw before, I get that simple 25 thou offset. Same token, I could come over here and put 0.350, jump over to the program, cycle start, and there you see the offset. So it's just a nice, simple little trick when dealing with programs with compensation. Whether you use 0 offsets in the tool table, quite common, very acceptable, or use true offsets. I like using true offsets in the table. I think it makes it a little easier for operators. You know, if you're setting up a 1/2 inch end mill, put 250. And this way, if you know you're doing regrinds or it's undersized or oversized, you can put that true amount, and you're not always kind of guessing. So this would be the trick, using the TOFFR statement. Now, what I do also want to show you here towards the bottom of the program is CAN cycles. So this program drills a couple holes. So now, when you're dealing with CAM systems, the system itself, we'll go down a little bit further, go to our first spot drill here, you see it right down here. The system's going to output a CAN cycle. And this is how CAN cycles look in the Siemens world. So you have an MCall statement that sets up modal drilling, and then you have a cycle 81. I go down a little further, you're going to see a cycle 83. So it's just a different type of drilling cycle. Well, when you're on the system, even though it was posted from a CAM, as long as they're using our CAN cycles, you can actually launch what we call the data mask. And what the data mask is our controls automatically have conversational programming built into the cycle level. So I can open up the cycle, validate, or maybe make some changes like, hey, I want to change the depth of my spot drill because it was a little shallow, without having to go through and repost it. If you're always letting the CAN system put out point to point and not use any CAN cycles, then you start to lose the ability of making quick changes at the machine tool. So here, I could simply say, hey, I want my spot drill to go -0.2, accept it. It updates the appropriate field in the cycle. That would now apply as I run the program. But the other thing you're going to use this for is for debugging of posts. Probably the most common mistake that you're going to find a post that gets written is going to undergo in the system, in the world, is how they build our CAN cycles. So what you're going to do is when you're first checking out that post and validating whether the post is correct or not, you want to have them build up a bunch of CAN cycles. And then what you're going to do is you're going to open the CAN cycle, and the first thing you want to look at is how many blank spaces are here. Some blank spaces are okay, but that usually tends to throw up a red flag that you want to pay close attention because they probably are not filling out all the variables. So then I would just simply go through the actual resulting cycle and validate that it's all correct, that the depth was in the right field. Because if they built the placement wrong when they post it, like, oops, we were off a position, so we put the drill depth of 0.6 right here, one place down, so now it's affecting a reference plane, or maybe I moved it up and all of a sudden my drill depth is under my safety distance field. Those are the things that are going to get mistaked initially when you're first building a post-processor. So use this mask as a quick way to not only obviously modify the program once you're in production and making parts, but validating that the output code out of the CAM system is good in the first place. Okay. So now I create a part, I'm ready to run. From here, when I want to run a program in the 808, I simply hit the execute button, and that's going to automatically put me to my auto mode. I could run the part from the beginning just by simply hitting cycle start and letting the system run. Now, we do have what's called real-time simulation or real-time graphics. So if you hit the real-time simulation function, I'll put the auto zoom on and delete the window. I can see real time as the machine's running. You know, you crank an override down and it stops, the graphics would stop, start back up, machining out my given part. Now, two features I'd like to show you real quick. One is how do we pause midstream of a part program, maybe pull away, check some dimensions, clear some chips, and return to that point and continue cutting. And the next would be how do I just randomly start anywhere within the part program that I want. So within the system, while I'm running, so I'm going to crank my feed rate override down, give me some reaction. So the machine's running, it's cutting, it's doing its thing. I need to get in and check something. If you simply hit cycle stop, the machine will pause, and I now have the ability of going to jog, moving the machine up and away, getting in a safe position, doing what I need to do, and now she retained the point at which I stopped. And I never at one point hit reset. See, it's still in a cycle stop state. Don't hit reset. So reset will clear it, it'll lose that point that it stopped at. But as long as I'm still in the cycle stop condition, I can simply go back to my auto screen and watch what happens here. I got the crank down. It's going to vector. So it's going to go shortest path to the point at which I stopped and then continue cutting. So simply hitting cycle start would reposition that cutter right back down, picks up that point, and continues machining. And you can, what we're going to do now is let's break for a second because I do see a couple questions coming in. Can I search by a block? Yes, you can. When I did that search command, I have this search field, so I can type in actually anything unique here. So if it was a T measure tool, they are not available when you're in ISO mode. We're trying to make this kind of run more like an ISO-based program. So 40, 49, standard header statements, G80. Tell it to do a tool change. We have a tool change protocol right here. I do not have the, do that. Each number does not exist. Switch gears a little bit, and we're going to start to look at a little bit more higher technology type of features or functions. So we're going to, let me just shut this down for a sec. We're going to go back to our PowerPoint, and we're going to keep jumping into the wrong one, excuse me. We're now going to start to talk about what I call 3D surface machining. So in this scenario, we're actually going to take a part that was machined as a three-dimensional surface file, and we're going to start to play around with it and show you a couple different ways to utilize those programs on the control, give you a couple little tricks as to how to work with those types of files, because they can be pretty substantial. So you will want to, certainly get a chance to start to see some of this stuff. And this is definitely area of navigation. Certainly I can use the block search function. It's a great and powerful function for doing this kind of stuff. But you're going to find GoTo is also a very, very powerful tool to be able to move around through programs really, really quickly. From there, we're then going to start to look at our high-speed cycle. You would want to give that value. Now, what is the value really doing? Well, what it does on our end is in Cycle832, that program, this large file, doesn't fit in my system. So let's say, for argument's sake, this is the scenario we have today. So I am going to delete the program. So on the 808, as well with our other controls, you have the ability of running programs from any external surface, external memory allocation, shall we say, or devices. So just like that, I can be sitting on the USB. Now, the limitations of the 808, for one, I can't edit the file while it's on an external device. So if I hit the input key or I try to open it any which way, it won't open. You would have to, if you needed to make any editing or modifications, do it externally. But what I do is I use this external execution button right here. And that's what's going to put the system into memory. It's automatically going to switch me to auto and get me ready to run. So this right now, as I hit cycle start, this is physically running off of the USB stick. You do have to remember that procedure, however. You got to make sure that you go Program Manager, highlight the file wherever it exists. It could be on a network drive, it could be on RS-232. Hit the execution button. External execution is what it stands for, EXT, execution. And then cycle start and start running the program. Okay. So now what we'll do, though, is now we're going to switch gears and look at methodizing this part with a main program subprogram structure. So if there isn't any values, any R values set up in your part program, what the system will automatically do is go over to the offset table, go to its R variables, and look for R30 in this column. So if you don't want your R variables in the part program, maybe you don't want operators going in and editing that, you can have them go to this column right in the offset table, and they can write them right here. But it's always going to utilize what's in the part program over what's sitting in this table. So this is only a secondary if it doesn't get written anywhere else. So as well, I did the same thing for feeds. Here you see we have some R's, R20, 21, 22. If I go back into my roughing program, it's mimicked in all the other operations. Now I'll get down to the feed statement. Right there, here's my feed, F equals R20. It's that simple. And you can use R variables in the middle of CAN cycles. You can use them all over the place. So play around with them. Feel free to kind of manipulate them a little bit. Now, a couple of the other modifications I did in turning this into a subprogram is I commented out. I could have deleted, certainly. I commented out all tool change commands because I want to do that up in the main. I don't want to have nested tool changes. I commented out any kind of advanced technology cycles, corner rounding, feed forward functionality, anything like that. I don't want here. I want pure cutter path. Whether I want the spindle and feeds is really up to you. I'm not that concerned because I'm passing them through with R variables. But you don't want to have operators have to go into the subs to make any editing changes. The only area they should go into, if any of them, would be certainly in the main program file. So I just commented out these lines. You know, if this was a real part that I was going to do in production, I would just delete them. No need to see this kind of stuff. And then from there, the part program, it's a matter of setting up my normal header statements, G90 absolute, G94 inch per minute, G17 is your standard XY orientation plane, G700 is a metric mode. I'm using my SUPA statement. This is a rapid retract statement, so it suppresses any work coordinates, cancels my tool offsets. That's what the D0 statement does. Puts it into a rapid mode and tells the machine to go away. Any of this stuff, if you're not familiar with it, I certainly recommend go back to my earlier 808D milling webinar I did a few months back. We go through all these commands in a lot more detail because we actually write a live exercise. Work coordinate, whatever work coordinate you want to use. Now, I can use this go-to, and we'll use this in a little bit to jump around a little bit. We talked about that one. Then I do a tool change, load my tool. Now, you see, I like to put this D1. This is what tells the system what offset I want to load. You don't have to. Earlier, we saw they weren't using the D command because the system will automatically load based on that T command if the parameters are set up that way. That was why we actually had the problem we did with the prefetching, because this one's machine set up to load tools on the T code, but once you put another T code in, it supersedes the last. Okay. Tool change. Now there's our Cycle832, and we'll start to play with this here in a second. And then this right here is how I physically call up my subprogram. So the system is smart enough that if you just give it simply the name of the file, so op1_rough. If I look back up here, op1_rough. Don't need any extensions, nothing. So just simply give it the name of the file. As you see it here, op1_rough. And the system will automatically start looking within its own internal memory. Wherever it finds that program, it'll start to run that program. Now, if the program exists outside of NC memory, meaning it's sitting on a USB because it was too big to fit in the machine, sitting on a network drive or RC32, then what you would do is you would use an external call statement, EXTCALL. So if you start to play around with this a little bit and you want to call files that aren't even in machine's memory, you can do that. Just use an EXTCALL, external call. Further down, I changed tools again. In this case, I'm using the same tool. I repeated the tool change statement. It's redundant, but when I'm bouncing around, it allows me to bounce a little further down the program. So I can jump over this tool, but still force a tool change down here if I wanted to maybe just jump over to the semi-finishing operation. Same scenario with my finish tool. So there's my finish tool. Now I showed you a couple different ways to call it. I can use the call statement like I did in these next two. And then in there, you type in call, and then in parentheses and then quotations, again, the name of the file. So you can either just write the name of the file, or you can type in call if you like it to look a little more structured. Either way, you'll find we're very forgiving with a lot of type of commands in that way. So we load it up. Down here in the bottom, I'm doing my normal shutdown. Shut off my spindle, shut off my coolant. I'm canceling my tool, so I'm clearing my spindle. I'm disabling my tool offset. I do a quick tool change to actually clear the spindle. I use the super command again to stage my tool, or to stage my table and a safe point for loading, and I shut off my program. So you can certainly simulate these types of programs. If I delete the window and if we were to run again, I can fire it up, and it's going to do everything you saw before. So here it's already in and running the roughing cycle. And then from there, once it roughs it out, it's going to jump over to the other two operations. So even with subprograms, I can still simulate. There, it just jumped over to the other one. Then you'll notice as it gets down past this one, it's going to even jump into the finish cycle. So you still have all that capability you had before. So there we're into the finish cycle. It's rolling around it. Great way to let it run through just to make sure that there aren't any errors or problems prior to physically running the part program. Okay. Now, when it comes time to run the program, I simply go to execute from while inside the main. So this is all our main. So now as I start to run it, I'm going to crank down my override a little bit. See how the current program says surface main? It's telling me where I am right now. As I cycle start and run it, once it jumps in, it's going to always tell you where it sits. So you're never even kind of wondering, gee, which of the subprograms I'm in. Just look at the screen. Right now I know I'm in my op1 roughing. As I start to crank up my feed rate, as we finish this segment of it, you're going to see it's going to jump over to op2 semi-finishing, and then even to op3, the finishing routine. So it's always kind of keeping track of speed and surface quality and tolerances of the part program as it's running right here. As well, the dyne norm was on before. Now I'm in a dyne finish. That's because I'm in a finishing routine. As you change from roughing to semi-finish to finishes, you're going to see these different statements change, and that's triggering a whole bunch of stuff in the back end. So this is how I can validate that Cycle832 is actually doing something, because I start to see all these commands being triggered as I go. Okay, so we're 7 minutes, 48 seconds if memory serves me. So what would happen if I was to go into the program and change this Cycle832 right here? I was just staying away by a certain amount. I think I left 20, 30 thou on the surface. So now if I looked at it, I was tightening up my tolerance, and I was down here in my semi-finishing. My two lower diamonds were triggered. And then from there, I went down to the full finish. This is where I was really concerned about my dimensioning